Okay, so we're still working on limits, and what we're now going to do is we're going to learn how to identify limits when we're given a graph of a function. So this is the graph of a function. It says this is the graph of the function f of x. Now I know this looks crazy. I want you to understand that this is a piecewise function. Okay, you can see that here, if we go over here to -8, it's kind of a parabola, but when it gets to -4, it switches up and becomes a linear function until it gets to -1, and then at -1 it becomes another kind of function. Looks like it has a vertical asymptote here at -1. Okay, and it's got a weird change up over here to 4. And then at 4, it looks like it becomes something that has a vertical asymptote again. And then at -6, it looks like it becomes a parabola, a quadratic function again. Okay, so I understand that this is very strange looking, but it's very useful for helping us to be able to identify limits of functions when we're given graphical information. Now, if you look over here, we're only going to do a few of the numbers, not a lot of them. We're going to identify the limit as x approaches -5 from the left of the function f of x, which is this is the graph of. Then we're going to do the limit as x approaches -5 from the right side. So we're going to do both the left side and the right side, but we're going to do them separately because we're doing one-sided limits in this lesson. Okay? All right, now here's what I want to remind you is that the vertical axis is the y-axis and the horizontal axis is the x-axis. So when it says as x approaches -5, we're going to go to where x is equal to -5, which is right here. Here's where x is equal to -5. And approaching from the left means being over here and moving this direction towards -5. To approach -5 from the right, here's -5, we would need to go to the right side of -5 and move backwards to approach -5 from the right, okay? Because we can approach -5 from the left, or we can approach -5 from the right, okay? And then the answer is going to be the output value of the function. Well, graphically, the output value is the height of the function. So what is the height, for example, this linear piece? What is the height of this at -3? Well, we go up 1, 2. See over here, 2. These are the y values. And so all the values that are along this y-axis, those are going to be the answers to each of these limit problems, okay, if there is an answer to them. So let's do this first one here. What is the limit of f of x as x approaches -5 from the left? Okay, well, all we have to do is go to -5 from the left, okay, and then go to, so what I'll do is maybe go to -6, and I'll go up or down to where the graph is. I want to follow along the graph until I get to -5. So moving from the left, here we go, here's -5. I'm approaching -5, and boom. Well, what is the height of this function as I approach -5? Okay, well, we're coming from the bottom, we're going up, right? That means that the values are getting larger and larger and larger, and as x is approaching -5, y is over here approaching the height of the function, which is -1. And so the answer to this really is just whatever the y coordinate is right here, okay? So the answer is going to be -1. So over here, we would put -1. By the way, there's a picture of this. I should have told you this at the beginning of the video. There is a file, a PDF file that has this on it under day 1. If you want to print that out before you watch this video, you can print that out and take notes on it instead of having to draw this thing. You don't have to draw this thing yourself, okay? Okay, so now let's move on to this one. What is the limit as x approaches -5 from the right? So we're going to the exact same place, but instead of approaching from the left, we're going to approach from the right, from the higher value. So we're moving from -3 back to -5. Well, like I said, go to where the graph is and travel backwards along the graph. Okay, so we're moving from -4 back this way, but that means following the curve down here. Well, what is the height of the function at -5 here? Well, it's -1 again. All right, well, the answer over here is -1. You might say, well, what was the point of doing that? If the answer is -1 here and -1 here, won't the answers be the same for all of them? Can't I just answer one of them and then just put it in the other one? No, you're going to find in some of these places the answer is different coming from the left than it is coming from the right. In fact, let's move on to this one, and you'll see that it's a different answer. So what is the limit of f of x as x approaches -4 from the left? So we want to go over to the graph. Here's -4. We want to go to the left of -4 and travel along the graph until we get to -4, and boom, here's -4. And what is the height? The height is 2. So the answer to this limit is 2, okay? All right, now it says, what is the limit of f of x as x approaches 4 from the right? Okay, well, here's -4. Let's go to the right side. Let's go to -3 maybe, and we'll work our way backwards to -4, okay? Well, if I go to the graph here and work my way backwards to -4, well, look, what value am I approaching up here? Now, you might say, well, Mr. Ryan, there's an open circle there. That means that there's no output value. It doesn't matter if there's no output value. We don't care what's happening at -4. We care what are we approaching. What height are we approaching as we go backwards towards the input value of -4? Well, as we work backwards here, we are approaching this height right here. This is the height, which is +4. So the answer to this limit is going to be +4, okay? Now, so the answer over here is 2. The answer over here is 4. I've just proven that the answers to both sides might be different depending on the circumstance. Now, the reason that happened is because we have what's called a jump here, a jump discontinuity. We'll talk about those later in the semester. All right, how about at -1? As f of x as x approaches -1 from the left. Well, here's -1, and if we go to the left of -1, here's this graph. As we travel along the graph towards -1, what height are we approaching? We're approaching this height right here, right? And that's a 2. It doesn't matter if there's an open circle. It doesn't matter what's happening at -1. It just matters what the height is as we approach -1 from the left. So the height of the function as we get to -1 is 2. Therefore, the answer to this, excuse me, not 2, that's a -2. It's below the x-axis. So the answer to this one is -2. Well, what about as x approaches -1 from the positive side? Okay, well, here's -1. Let's go to the positive side. Here's the graph, and let's go backwards towards -1. Well, what's this graph doing? It looks like it keeps going up and up and up and up and up. It doesn't look like it's actually hitting -1. That's right. This line right here, this dashed line, indicates that there's a vertical asymptote. This graph is going to positive infinity. And so the answer to this limit from the right side is going to be, you can either say positive infinity or you can say DNE for does not exist. Okay? All right, let's move to this one here. What is the limit of f of x as x approaches 1 from the left side? Okay? All right, well, here's 1, not -1. This is +1 from the left side. Here's +1 from the left side. So we're going to go to the left side of 1, and we're going to go to the graph, and we're going to go toward 1. Okay, here's 1. This whole vertical line right here represents an x value of 1. As we approach an x value of 1, what is the height of the function approaching? Well, it's approaching this point right here, which is 3, right? This height right here, or excuse me, that's -3, which is a -3. Therefore, the limit of f of x as x approaches 1 from the left is -3. Well, what if we approached 1 from the right side on f of x? Okay, well, here's 1. Let's go over to the right side at 2, go to where the graph is, and we'll work our way backwards toward this vertical line, which is right about here. This vertical line represents an x value of 1. We're going to move toward that x value. Well, what is the height? What is the y value as we approach this point? Well, the y value at the end of this line right here at this point is -3. So the answer to this one is -3. Just like this one was -3, this one is also -3. And that's going to happen a lot, okay? All right. Now we're going to move over here to the limit of f of x as x approaches 2. Okay, well, here's 2 right here. As x approaches 2 from the left, what is the height we're approaching? Well, this height, this point right here, we're approaching this point, and at this point, the height is -2. Therefore, the limit of f of x as x approaches 2 from the left is equal to -2. Well, what about approaching from the right? Okay, well, here's 2. We'll go to the right, go to the curve. We're going to work our way backwards towards an x value of 2, and we're going to arrive at this height right here, which is the same as it was coming from the other direction. so the limit is -2. So the limit of f of x as x approaches 2 from the right is equal to -2, okay? All right, now let's go to +4. Well, here's +4. Well, what's the limit of f of x as x approaches 4 from the left, okay? All right, well, approaching from the left toward 4, it looks like we're going to this height right here, and it doesn't matter that it's an open circle. We don't care what's happening at the point. We care what height we're approaching. And it looks like we're approaching this height right here, which is -1. So the limit of f of x as x approaches 4 from the left is -1, okay? What about approaching f of x as x approaches 4 from the right? Okay, well, here's 4. Let's go over to the right and work our way backwards. So from the right, we're going to go to where the graph is, which is right here. We're going to work our way backwards. Well, what height are we approaching as we go backwards? It's this height right here. Well, what height is that? That's a height of +3. So the limit of f of x as x approaches 4 from the right is equal to +3. All right, the last couple we're going to do here. What is the limit of f of x as x approaches 6 from the left? Okay, well, here's 6. You can see that there's one of these dashed orange lines. So that means a vertical asymptote. So as x approaches 6 from the left, here's 6. Here's the left. We'll go to the graph, and we'll approach 6 from the left, and it looks like we're not getting close to any height. It looks like it's going vertical. Well, whenever the graph goes vertical next to one of these dashed lines, that means that it has a vertical asymptote, and therefore it looks like it's going down to -infinity. And so the answer to this limit is either -infinity or dne, okay? And so lastly, we're going to do the same limit of f of x as x approaches 6, but from the right side. So here's the 6. We're going to go to the right side. We're going to go up to the graph, and then we're going to go backwards towards 6. Well, as we go backwards towards x equals 6, look, we're approaching this height right here, okay? And that height is 5. And therefore, the limit of f of x as x approaches 6 from the right is equal to 5, okay? And so that's just a basic example of how to identify limits on a graph. All you're doing is going from one direction toward the x value on the graph and then just identifying the height of the function at whatever point that is, okay? All right. I recommend, if you're not sure about this, this can be very confusing. You may want to send me a message, and I'll see if I can find maybe a couple other videos that might help you. But I think after practicing a good bit, the practice problems that I'm going to give you are going to be maybe a little bit easier or less clustered on the quiz. Okay, I'm probably more likely to give you just one shape instead of 5 or 6 different shapes on the quiz. Okay. All right, now we're going to move on to the last thing we're going to do in this in this lesson for this day is a segment on doing one-sided limits analytically.